In this lesson, I'll show you two examples on how to find the radius of convergence of a power series. The theorem that we'll be using throughout this video is shown right here, and it states, where for a given power series, denoted here, there are three possibilities, and our main focus will be number 3, where there is a positive number r such that the series converges if the absolute of x minus a is less than r and diverges if x minus a is greater than r. This number r is called the radius of convergence. Question number 1 is an easy one. They're asking us to find the radius of convergence for the given series. To do this, we'll use the root test because both the terms at the top and the bottom of this fraction are raised to the power of n. And if you don't recall, the root test is shown below. So we'll take the limit as n approaches infinity for the nth root of the absolute of our series. If that's confusing, here's what you do. You take the limit as n approaches infinity for the nth root of our series in absolutes. And instead of writing cosine to the power of n, I'll write down cosine 7 over n, all raised to the power of n. I'll rewrite this as the absolute of x minus 2 over cosine 7 over n, all raised to the power of n. And rather than this radical, I'll write it in fractional exponents. The good thing about this is that if we multiply the exponents together, we end up with no more exponents, an exponent of 1 technically. And if we take the limit as n approaches infinity for the bottom term, we end up with 7 over a very large number. That becomes 0. So cosine at 0 is equal to 1. So this becomes a 1. We've taken the limit. We have x minus 2 in absolute. And this power series converges according to the root test when the limit is less than 1. It's shown right here. According to this theorem, if we can write our series in such a way, the radius of convergence is this number r, which in our case is 1. Therefore, r is equal to 1. That's the answer to question number 1. Let's move on to question number 2. Once again, we're asked to find the radius of convergence for the given series. For this, we won't use the root test. Instead, we'll use the Cauchy ratio test, which is shown right here. Cauchy, that's another way to say the ratio test if you want to be more formal. And according to the test, what we have to do is take the limit, once again, as n approaches infinity, in absolute, where we take our series and substitute all the n values with n plus 1, and then we divide by the series itself. So let me go ahead and do that. The top part becomes 8x minus 3 raised to the power of n plus 1, and the bottom becomes 7n plus 1 times n plus 1 times 9, which is n plus 10, raised to the power of 2, and this is being divided by the series, which is 8x minus 3. It's written right here. 7n, n plus 9, raised to the power of 2. Remember that when you divide fractions, you flip the second fraction and multiply instead. So I'm going to show that. There you go. Now, I'll rewrite 8x minus 3 n plus 1 as 8x minus 3 raised to the power of n and 8x minus 3. This orange expression and this expression mean the same thing. The reason why I'm doing it this way is because this now will cancel out with the bottom, and we're only left with 8x minus 3. And similarly, this 7 to the power of n, for the same reason why these two canceled out, will cancel out with 7n here, leaving us only with 7 to the power of 1, or 7. Now we have the limit as n approaches infinity for 8x minus 3 times n plus 9 raised to the power of 2 over 7, and this expression, times n plus 10 raised to the power of 2. Let's algebraically manipulate this further. I'll group these two factors together, 8x minus 3 over 7, and I'll put those in absolute, and also group these together, where I have the limit as n approaches infinity for n plus 9 over n plus 10, all raised to a power of 2. Taking the limit as n approaches infinity for this will end up giving you 1. And you can prove that in many ways, either the L'Hopital's rule or some sort of algebraic manipulation. Therefore, we're left with the absolute of 8x minus 3 over 7. According to the ratio test, we're told that it converges when this part is less than 1. If I multiply now both sides by 7, I end up with 8x minus 3 is less than 7. And dividing every term by 8 makes this go away. We end up with negative 8 over 3 here and less than 7 over 8. So we have x minus 3 over 8 in absolute is less than 7 over 8. This means that this part is r. And there you have it. That is how to find the radius of convergence of power series.